Alright, so in this video, I'm going to be solving the equation x squared minus x to the power of 3 is equal to 12. So to start, our only variable is x in this equation. So I want to find the value of x. And for my solution, I'm going to first start by rewriting 12 as 4 plus 8. So I get x squared minus x to the power of 3 is equal to 4 plus 8. And the reason I did that was because 4 is the same thing as 2 squared, and 8 is the same thing as 2 to the power of 3. So notice I have a number squared minus a number to the power of 3, and then I have a number squared plus that same number to the power of 3. Now I'm going to subtract 2 squared on both sides and 2 to the power of 3 on both sides. So these two cancel out, and I get x squared minus x to the power of 3 minus 2 squared minus 2 to the power of 3 is equal to 0. Now I'm going to group all the powers of 3's and the powers of 2's together. So I get x squared minus 2 squared minus x to the power of 3 plus 2 to the power of 3 is equal to 0. So if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So x squared minus 2 squared is going to equal x plus 2 times x minus 2. And now if I have something in the form a to the power of 3 plus b to the power of 3, this is going to equal a plus b times a squared minus ab plus b squared. And these two properties are really important in algebra, so I would recommend memorizing them. So now I get x plus 2 times x minus 2 minus x plus 2 times x squared minus 2x plus 4 is equal to 0. Now notice how both of these terms have x plus 2 in them. So if I factor out x plus 2, I get x plus 2 times x minus 2 minus x squared minus 2x plus 4 is equal to 0. And this turns into x plus 2 times x minus 2 minus x squared plus 2x minus 4 is equal to 0, which equals to x plus 2 times negative x squared plus 3x minus 6 is equal to 0, which turns into x squared minus 3x plus 6 is equal to 0. Sorry, it's not. This is still negative x squared plus 3x minus 6 is equal to 0. Now from here, this gives me two equations. X plus 2 is equal to 0, and negative x squared plus 3x minus 6 is equal to 0. So for x plus 2 equals 0, I can subtract 2 on both sides, and I get x is equal to negative 2. Now for negative x squared plus 3x minus 6 is equal to 0, now I can divide both sides by negative 1. So I get x squared minus 3x plus 6 is equal to 0. So now to solve this quadratic equation, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get 3 plus or minus the square root of 9 minus 4 times 1 times 6 all over 2a, so 2 times 1, which is equal to 3 plus or minus the square root of 9 minus 24 over 2, which is equal to 3 plus or minus the square root of negative 15 over 2, which is equal to 3 plus or minus the square root of 15I over 2. So these are two other solutions to my equation. Alright, so in this video, I'm going to be solving the equation 7 to the power of x is equal to 70. So before we start on our solution, let's notice that this is an exponential equation, and x is an exponent, which is the variable we're solving for. So let's just try to plug in a number. Let's start with 1. So we have 7 to the power of 1, and this is equal to 7. Now, let's go one higher. Let's go 7 to the power of 2. This is equal to 49. And now let's go one higher. Let's go 7 to the power of 3. This is equal to 349. So notice how we're trying to find what value of x that we should take the power of 7 to equal 70, but even the number 3 results in a number much higher than 70, meaning the value of x is going to be a decimal somewhere in between 2 and 3. So now to actually solve for x, my equation is 7 to the power of x is equal to 70. And what I'm first going to do, and what I recommend doing for any exponential equation such as this, is taking the log on both sides. And the reason that you should do this is because now you can use the property log a to the power of b. I can move this b to the front, so I get b times log a. Log a to the power of b is equal to b times log a. And the reason this property is so useful is because before, x was an exponent, and it's really hard to solve for x in its previous state. But now I can move x to the front, and it's going to be an actual term. So now I get x times log 7 is equal to log 70. Now, log 70 is the same thing as log of 7 times 10. And another property of logarithms is that if I have something in form log a times b, this is equal to log a plus log b. So log of 7 times 10 is going to equal log of 7 plus log of 10. So now from here, what I'm going to do is divide both sides by log 7, because we obviously want to isolate x, so the only way to do that is to get rid of this log 7. So then these two cancel out, and I get x is equal to log 7 plus log 10 over log 7. And I can rewrite this as log 7 over log 7 plus log 10 over log 7. Now log 7 and log 7 cancel out, so I get x is equal to 1 plus log 10 over log 7. And if you guys already know, log 10 is actually equal to 1. So now I get x is equal to 1 plus 1 over log 7. And this is my answer.